AI-driven cybersecurity for the business enterprise. Cybersecurity is the practice of defending computers, mobile devices, electronic systems, servers, networks, and data from malicious attacks. With millions of virtual cyber attacks that occur every year across most industries, cyber criminals pose a significant threat to business enterprises, their customers, and consumers. All businesses that use networks can be targeted for customer data, corporate espionage, or customer attacks. The Online Trust Alliance estimated that there were more than 2 million cyber attacks in 2018 that resulted in $45 billion in losses. According to a study in 2019 by Accenture Security and the Poneman Institute, the average cost of a cyber crime for a business or organization is $13 million, which is likely to increase. In the US alone, there were more than 10 billion data breaches since 2005, with Yahoo leading the pack with more than 3 billion pieces of data that were leaked in 2016. When large data breaches occur, personal data concerning hundreds of thousands of individuals can potentially be leaked, opening the door for cybercrime and fraud for each individual. GitHub was another cybercrime example in 2018 when it was victim of one of the biggest distributed denial of service attacks of all time, where a huge number of requests were sent simultaneously to overwhelm the server, which was unable to process them. In the ever-changing cyber threat landscape, with an increasing number of data breaches, hackers' attacks, and crashes, cybersecurity is more vital than ever. Although the rollout of super-fast wireless communications technology, such as 5G, will bring massive opportunities for businesses to provide services in fresh and innovative ways, they will also potentially lead to more sophisticated cyber attacks. IT security departments in businesses will need to dedicate entire teams and smart technology solutions to risk prevention. Elements of cybersecurity include information security, network security, application security, disaster recovery and business continuity planning, operational security, and end-user education. One of the most problematic elements of cybersecurity is the rapid and constantly evolving nature of security risks. As the traditional approach focuses most resources on the most crucial system components and protect against the biggest known threats, it leads to leaving some less important system components undefended and some less dangerous risks not protected against. Such an approach is insufficient, and a more proactive and adaptive approach that involves continuous monitoring and real-time assessments is required. Common methods attackers use to control computers or networks include viruses and worms, which self-replicate and damage files or systems, spyware and trojans, which are often used for secretive data collection, and ransomware, which waits for an opportunity to encrypt all the user's information and demands payment to return access to the user. Malicious software code often spreads via a legitimate-looking download or an unsolicited email attachment that carries a malware payload. It is hard for businesses to fight off cyber attacks or predict the next big malware threats. We have, for example, already seen major threats such as Zeus Trojan and Locky ransomware being followed with new ones such as Emotant Botnet and TrickBot Trojan that deliver Ryuk ransomware. These threats need to be modeled via a process by which potential threats can be identified, enumerated, and prioritized, all from a hypothetical attacker's point of view. The purpose of threat modeling is to provide IT security teams with a systematic analysis of the probable attacker's profile, the most likely attack or threat vectors, which is a method or a path by which an attacker gains unlawful access into a system, which can include email, web applications, remote access portals, mobile devices, users, and the network, and the assets most desired by an attacker. Example threats involves malware, includes ransomware, insider abuse and negligence, includes information leakage, phishing, includes spam and is a form of fraud used to gain access to data such as personal information or login credentials. Targeted attacks includes botnets, identify theft, web attacks, exploit kits, and data breaches. Denial of service, service providers and business partners, physical loss, and espionage. Threat agents can be cyber criminals, which is typically financially motivated, often indiscriminate. Insiders, typically disgruntled or dishonest employees. Script kiddies, copycats and/or hack for fun or grudge. Cyber spies, nation-states or competitor-sponsored actors. Hacktivists, and cyber fighters or terrorists, naturally or religiously motivated groups. The next generation of cybersecurity solutions are increasingly incorporating AI components and systems which are being trained on large datasets of cybersecurity, network, and physical information to detect and block abnormal behavior. This might involve analyzing raw network data to spot an irregularity or detecting patterns in user, asset, and/or entity behavior that deviate from normal. The types of data streams, how they are collected, and the level of effort needed by IT security teams all vary by approach. The use of unsupervised and supervised machine learning enables businesses to not only tap into the current knowledge of threats and vectors in order to detect new attacks and discover new vulnerabilities, but also deliver automated solutions that can help to eliminate human error, work simultaneously on various tasks, monitoring and protecting a vast number of devices and systems, and mitigating large-scale attacks. AI-driven cybersecurity not only offers insights that enable businesses to understand threats easily through unsupervised machine learning and analysis of huge volumes of security data, data classification for forensics, and threat intelligence feed curation, which all helps to reduce response times and making companies compliant with security best practices, but also help to detect, prevent, and respond to novel, abnormal, sophisticated, AI-assisted, and unanticipated attacks. We already see AI in the form of supervised machine learning being deployed in spam filter applications, malware classification, network intrusion detection and prevention, secure user authentication, hacking incident forecasting, botnet detection, cybersecurity ratings, and fraud detection. Online transactions can be secured by identifying fraudsters through machine learning models that proactively detects fraud in financial transactions or fraudulent users on websites and in mobile applications. AI can not only be used to identify and grade risky behavior in mobile applications, including known and unknown malware, new malware used in targeted attacks, intellectual property exposure, and corporate data exfiltration, but also helping to secure applications by finding, fixing, and monitoring web, mobile, and networks against current and future vulnerabilities. Similarly, AI-powered asset protection software can be used to assist with the security, reliability, and safety of the IoT and allow for a preemptive response to data theft. For example, by identifying hidden transmitters or recording devices in a business meeting room. AI will play an increasingly important role in protecting businesses from cyber threats, with security tools analyzing data from millions of cyber incidents and using it to identify potential threats, such as phishing, hacking, and social engineering attacks, or a new variant of malware that are becoming ever more sophisticated. AI can be used to identify signals within digital activity or transactions that follow patterns that are likely to be indicators of criminal activity and give warnings before defenses can be breached and sensitive data compromised. These anomaly detection and behavior analytics are based on finding matchings to profiles that represent the normal behavior of users, hosts, or networks, and detecting attacks as significant deviations from this profile. In the case of new variants of malware, machine learning signatures and AI models can be trained to orient to these variants when they appear. To distinguish between harmless software and malware, machine learning models can be trained on data using features such as consumed processing power and bandwidth, amount of data transmitted over the internet, and accessed APIs, fields on a disk, and environmental components such as camera or keyboard. There is also a constant battle between attackers and defenders, where so-called blue defensive AI security controls defend against red offensive AI-powered attacks, such as malware creation with enhanced and fast evasive capabilities, impersonation of trusted users, self-learning botnets, sophisticated threat actors that blend into background, faster attacks with more effective consequences, spear phishing with smarter social engineering and convincing scams, using real emails as training data, as well as attacking and theft of AI. Another dangerous offensive AI threat is posed by adversarial AI that discover and poison datasets and compromises the machine learning algorithm, which leads to the machine learning models producing false and controlled results, artifacts designed to fool defensive AIs, the stealing of models to enhance the abilities of adversarial inputs, and weaponizing feedback. If cyber criminals can hack their way into getting access to data, they can easily manipulate data to their benefit. For any type of attack, the information leakage and probing should be limited, and machine learning models should use ensemble learning and adversarial training as part of the defense. To defend against poisoning attacks, data cleaning, anomaly detection, and secure data collection are all key steps. Cyber criminals also take advantage of businesses struggling to defend their perimeter against unknown threats. This is where predictive and preventative AI-driven security can be used against these novel and advanced cyber threats to detect advanced persistent threat attacks and insider activities at an early stage. To proactively deceive and disrupt in-progress cyber attacks, there are also defense applications that create a neural network of thousands of fake computers, devices, and services that act like a fog and work under the supervision of AI algorithms. Some of the key AI-driven cybersecurity applications include integrating machine learning into firewalls to flag any anomaly, the monitoring and analysis of security incidents and mobile endpoints, using robotic process automation to automate rules-based processes and tasks, identifying the origin of cyber attacks through natural language processing applications, and handling the aftermath of an attack. Other applications include AI-driven security solutions that automate tasks and orchestrate a complete and dynamic response, enabling faster and more intelligent remediation based on detection and anomalous behavior in real time. This in particular helps to prioritize and reduce traditional security alerts, increasing the efficacy of security staff. Complexity continues to be a top concern for businesses and their information technology teams, where we see reactive strategies driven by threats, products and solutions being deployed in silos, and organizations and teams continue to work alone. Stressed and stretched IT security teams are looking to automation of cybersecurity tasks for relief. Given the scarcity of cybersecurity experts, as well as the evolving role of cybersecurity staff, there is a need for support from augmented, if not autonomous AI, to increase efficiency and help security staff to be able to meet more complex, massive, and time-sensitive threats. AI solutions can also help to orchestrate a complete and dynamic response, enabling faster and more intelligent remediation, and should be fully integrated and consistent with the existing IT and cybersecurity processes to be efficient. As with any other implemented AI-driven solution in the business enterprise, change management is important to ensure the full benefit from the expected innovation and quality improvement and cost reduction. Given that AI is how technology responds to our ever-changing world, the adoption of AI-based solutions is going to be key for any business to thrive and survive in the smart technology era. By keeping up to date with the state-of-the-art in AI-based cybersecurity tools and its correct deployment to assist security teams, this could help businesses stay secure against increasingly smart and potent cyber attacks. AI-driven cybersecurity solutions should update automatically and learn how humans react, with the ultimate vision for a business to end up with a self-learning and self-healing cybersecurity posture that can learn negative and threatening behaviors and stop them from happening.